So, let me get you guys the notes.
I know we have to go
Oh.
No, he goes out like 30 minutes before he leaves. I come out, it's like, not even working. What did you do? Windows not even be on. We need to drive all the windows down just so you can see where he's going. You kind of
I don't even want to get in my car if it's not warmed up in the morning.
Yeah.
like, yeah, Matt's like, oh, you know, you need to drive.
Oh my gosh.
I'm not even wearing them.
I start Mr. Donahue's car for him too. We don't ride in it because we can't, our timing is not good.
Why?
Are you so pokey in the morning?
Oh.
And like, it drives me crazy. And then after school, a lot of times he wants to stay to work out.
Oh.
And I want to get home to get the boys and.
Yeah. Well, the boys are not here, right?
Yeah, they come here a lot. Like tomorrow when they have baseball workouts, like I'll go get Peyton and bring them up here to work out. Yeah.
I have
Oh, didn't you show it to me already?
this was one that was marked missing, but I turned it in.
Oh, I'm sorry. They're coming here next year, so the boys.
Oh, they are? What grade?
Amy's gonna be a freshman.
Mm-hmm. And then Griffey will be a seventh grader.
What's the 12 and 6?
What do we do for this fire?
Yeah, we're allowed. They wanted to know what happens if there's a fire and a tornado.
It'll be Candelaria.
Then you just run.
Yeah. Once we were outside for fire control that I taught at Ground Deer, and all of a sudden, like the clouds, like kind of crazy, like scary. They were like, "Get back in the building!" So we were like, it was just a drill, but then the tornado alarm went off. But
I've been in 2 tornadoes and a hurricane.
Yeah.
One tornado down in Florida, one tornado up here. My dad, my brother, so I was home from college. And I'm down in the basement because the sirens are going off, and my dad and my brother are upstairs. My dad's like got his hands on the walls. He's like, "Hey, you gotta come up here. The walls are going in and out." I'm like, "No, I'm good, thanks."
I'm gonna go down this.
Stupid. Yeah, and then the one in Florida happened at like 3 in the morning. And we're in bed. Dakota's up in his crib, in his room. And it does. It sounds like a train and all that stuff that you hear about. It really does. And your ears pop because there's such a difference in the air pressure. all of a sudden. So like the wind picks up, you start hearing this sound, your ears pop, and I go whack, and I hit my husband, and he's like, "Ah!" And I said, "Okay." He goes, "Grab Dakota, get him in the," because you don't have basements in Florida.
That's right.
Yep. The water level is so high, it's like at sea level, so if you dig down even a foot, you're gonna have water. So, grab them, go in the closet. Missed our house, hit our neighbor's house.
Oh my gosh. I feel like I grew up afraid of tornadoes from like The Wizard of Oz. Alright. So that's just not hope for. I actually was thinking about a fire drill recently because I was like, oh, it's December, we have to do like our monthly fire drill. I don't be like this.
I like a
Yeah.
7:30.
Yeah.
You guys always get it. Well, I guess so that's it. Oh my gosh. Still.
Yeah.
You like big crashes?
No, stop.
It sucks.
I can't even imagine. Once I'm home, I'm like, I don't want to go anywhere.
Yeah.
Lisa's lives here.
Yeah, he goes.
Yeah.
He says he's not coming back.
All right.
We can't get us. I was surprised. Bro. Honestly, show up.
So since I know how much you guys all love simplifying radicals, again, the warm-up is simplifying radicals. So again, this is something we'll have to use throughout this chapter and kind of going forward. So simplifying the square root of 72 and simplifying the square root of 112. So again, you want to find perfect squares that go into these numbers. And so if I list some of our perfect squares over here, so these are the perfect squares up to 100. Any numbers other than these are going to be decimals. So like the square root of 72, I know is going to be a decimal because it's not on my perfect square list. So I'm trying to find numbers that go into the square root of 72 to simplify it. And when I mean goes into, my other class told me this yesterday, they didn't know what I was talking about. Goes into means just divides into evenly. So if I divide 72 by one of these numbers, it'll be a whole number as the answer. So I'm going to use these numbers, check and see what goes into 72. Now, I'll tell you guys, finding the biggest number possible makes this really, really easy. So what I usually do is I start at 72, and I kind of go like up the list here. So 72 is in between these two. So 64, if you divide 72 by 64, that won't work. 72 divided by 49 won't work. But if you divide 72 by 36, what do you get? 2. So 72 can be divided by 36. So I kind of use that list to help me. And that list, obviously, I'm a math teacher, so it's like kind of, it's easy for me to make that list. But if you're not super comfortable, kind of having that somewhere is good. The square root of 36, the reason I like this is the square root of 36 is just 6. So I can easily simplify if I find that big perfect square that goes into that number. So 36 is the easiest one to start with. Now, if you didn't notice that, 4 goes into 72 as well, but then you have to do another step when you realize I think 9 goes into 72 as well. So there's more work to be done there. So same thing with 112. So 112 is bigger than 100. Obviously, 100 can't be divided by 112. 81, 64, I don't think so. No. Kind of keep going down the list. 112 divided by 49. 36, I don't think works. 25 is 16. I think it does.
Yes.
It's 16 times 7, you said? So 16 times 7 is 112. And I would grab my calculator for that because I'm not dividing 112 by all these big numbers without grabbing a calculator. And then the square root of 16 I know is 4. The square root of 7 can be simplified because 7 only goes into itself, or 1 and 7 only go into 7. So that's as simplified as it gets. Now, again, if you have a calculator that simplifies for you, you're like, this is the piece of cake. But if you don't, just kind of try to show you where those numbers come from. So we'll be still using that more. So that's why I'm kind of keep reviewing it. Now, earlier, I think it was last chapter, we talked a little bit about geometric mean, and we're going to use those today. We're going to use the geometric mean today. So if you guys recall, this is the geometric mean, where the x shows up on the opposite sides of the proportion, and then the a and b are like the other two. So what I'm going to let you guys know, so x is called the geometric mean in this case. probably the bigger thing to know that X is actually the side that's gonna be used twice. And so in this drawing, we're gonna do a problem in a little bit, is that X shows up twice in our proportion. That means X is kind of like a shared side. And so we'll use that today, that X shows up twice in our proportion because it's used twice. And we'll see that in a little while here. So they asked for the geometric mean of 5 and 45. So they're looking for the value X that shows up twice in that proportion. So that would mean that 5 and 45 are A and B. Now, the fact that they use A and B is a little confusing because you're probably thinking A squared plus B squared equals C squared. Now, they could be that, but that's not what they're asking us to do here. They're just asking us to find the geometric mean. So the X's show up twice. So we cross multiply. So we get X squared equals 5 times 45, which is 225. 220. No, I'm not multiplying all in my head. 225, yeah. Yeah. And then to find X, I have to take the square root of each side. So it's going to end up being 15, I believe. So that'd be considered the geometric mean in this case. Sorry, I didn't print off my notes today. I'm stealing from my phone. All right, so this section is going to feel a lot like last chapter with all the proportional parts. So if you guys look at this drawing, there's actually 3 triangles here. So hopefully you guys see it, that there's a big triangle ABC, and then there's these 2 little triangles within that. What I'm going to tell you guys today is that all of these 3 triangles are proportional. They all share angles, which means that that angle-angle property applies. So these 3 triangles are all proportional. When they're right triangles like this. So I'm going to kind of show you guys when we use these types of problems. So there's this big right triangle. In this case, it's ABC. Inside of that big triangle, they have this altitude drawn. So an altitude, we talked about that a few chapters ago, is just the distance or the top. It goes from the vertex and it's perpendicular to the opposite side. We draw an altitude. And what that does is it forms these 3 similar triangles. So we have the big triangle ABC. It's going to be similar to these other 2 little triangles. Now the way I name this is a little bit confusing, so I'm going to make sure that it makes sense here to you guys. So we have ABC is the big triangle. Let's start with this green one over here. A is matching up with the other one's A. So that's going to be A. In the big triangle ABC, the right angle is the B, but in this one, the right angle is the D. So the way I name that is specific to the fact that the angles match up. And then finally, that's going to be similar to the right triangle. which is triangle BDC. So we have three similar triangles here. So we have large, medium, small. So if you guys can tell that I have my big one, I have the medium one, and then the small one. These are all similar. So what we're gonna do is we're able to solve these triangles if they give us just some parts. They're not gonna give us everything. They're just gonna give us some of the parts that go with this. So what I'm gonna suggest you do is kind of picture this almost if you could draw these triangles separately. And so I have technology, so I'm gonna pull these apart. I think. I don't want that one. I want the big one right now. So like if you can almost picture those being pulled apart. Now, you guys obviously can't do that, but I have the little right angles here, but then this is a right angle on that big triangle. And so what I'm gonna be able to do is set up proportions comparing the small side, the short side, to the middle side, to the long side. So I'm gonna call these as short, middle, and then hypotenuse. We have short, middle, or no, this is hypotenuse, middle, and then short, hypotenuse, middle. So I'm able to have all these different parts that I'm able to set up proportions. So the short side goes with the short side, the middle side goes with the middle side, the long side goes with the long side. So what I want to show you is I'll do it on this one up here. Where the geometric mean comes in is I'm going to call this altitude x here. And I'm going to call this side over here, this little side A, and this one B. This is little a, that's little b. And then x. So again, don't get this confused with a squared plus b squared equals c squared, although we will use that. That's not what we're doing right now. We're going to do geometric mean. So I'm looking at these two little triangles here, the two smaller ones. If you guys notice, x is a shared side. So they both use the x, right? They're both using that same x value. This is where the geometric mean comes in, is the fact that they're both sharing that x, but they both use it in a different way. In this left triangle, this is the shortest side. In the right triangle, it's the middle side. So I have to put them opposite each other in the proportion. This is where geometric mean is so important. So the x is shared, but it shows up twice. And then the a and b are the other two sides. So when we have a problem like this, if I know those two short sides, these two a and b, I can find x. And I'll show you guys an example of that when we flip to the back side here. So with actual numbers, if you flip to the back side, I don't know why, I guess example 1 already happened. So if you flip to the back side, example 2. So if you guys look at this, in this example 2, they give us that shared side of Z. So that's that side that's shared. But if you look at it, in the triangle up on the left, it's the middle length side. But in the triangle over here, it's the short side. So they're not the same type of side, so I'm going to put them opposite each other in the proportion. And then the other part of that triangle, so here's the short side, that's the 8. Here's the middle side of this triangle, that's the 25. So if that side Z is shared, and they give us those other two lines, we're able to set this up as a proportion. So we can cross multiply. And is that gonna be 8? I think that's 200, right? Take the square root. Is that right? Is that 200? Yeah. Now square root of 200 isn't a nice number. It's about 14.14. And I take the square root of each of those. So again, when that shared side shows up, we're able to figure it out pretty easily using this proportion. So example 3, see if you guys can set that up. Now they give you some other variables, so we'll talk about those in a minute. See if you guys can set up example 3 using this idea. So look at what's shared among them. I'll help you guys in a second. If you guys can tell how you're gonna set that up. And then if you're done with, like if you found X, see if you guys can figure out how you'd be able to find Y and Z. Think about maybe how you would do that. You don't necessarily have to go that far, but. All right, I'm gonna pause you here in a second, so if you're not quite done with it or waiting or whatever, that's fine, just sit tight here for a second, let's talk through it. So the shared side is which one? What's the shared side? It's the X. So the X shows up in both triangles. So I'm gonna put that opposite one another. What's the other side that corresponds with those? The other part of this that I'm gonna set up. The 4 and 10. So we do 4 and 10 because those are the two sides that are made up of with that altitude there. So I'm going to do this as x squared is going to equal 40. Take the square root of each side, and I find out x is about 6 point something. .32. So that's my x value. And you can look at it and make sure it makes a little bit of sense. Like if you got 40 as the answer, I hope you look at that and be like, that doesn't seem right. That doesn't seem like it would make sense in this case. So 6.32. Any ideas on how you're going to find the y and z now? Anyone see how you would find y and z, Dawson?
A squared plus b squared, c squared.
Yeah, this is where the a squared plus b squared equals c squared would come in, because we have 2 of the 3 sides of a right triangle. On this side, we also have 2 of the 3 sides of a right triangle. So we're able to solve this because we know this is a right triangle. Now I'm going to give you guys a little bit of a warning here, though. I really ask that you try to be as exact as possible when you're putting this together. So when I do a squared plus b squared equals c squared, the one side's going to be 10 squared. This is our c over here. Rather than putting 6.32 in, what do you think we should put in for our b? Yeah. Yeah, square root of 40, which will become 40 when I square. Why is this better than 6.32? There's a couple of reasons. Yeah, 6.32 is approximate. If you square it, it's going to be around 40, but it's not going to be exactly 40. So it's not as exact as we'd like it to be. also, if you guys heard, like, it was said, like, it's just gonna end up being 40. It's kind of a little bit nicer number to work with than 6.32 squared. So I can make this 100, square root of 40 squared is just gonna be 40, and that'll be z squared. I'll get 140 equals z squared. So that means z is gonna be like 10.9-ish, I'm assuming. Or no more than that, 11, right? Yeah, 11.83. And as much as I say how important simplified radicals are, the homework tells you to round your answers in decimals. So that's kind of why I went back to that a little bit. And then we can find that other y value, because again, we have a right triangle there. This is now the c over there. So I'm able to find that by using my a squared plus b squared equals c squared. But again, I'll do 4 squared plus, rather than doing 6.32 squared, I'll do square root of 40 squared will equal y squared. Look at 16 plus 40 equals y squared. So 56 equals y squared. So y is going to be 7 point something. 7.4. Right. So we found our x, y, and z pretty easily based off the fact that they have that common shared side. So we'll do the next example, and then we'll take a little like whiteboard break or we could probably do like would you rather. You guys seem to be doing pretty well with these. And then I'm going to show you guys a little bit more difficult problem. All right, so this next one, example 4, is a really similar problem. So I'm going to ask you guys to try this one again. So 5 and 6 get a little bit dicier. So why don't we do 4? Try to find your z. Have it already. Okay. So again, I would go for z first, because again, that's that shared side that they both have in common. So z is shared. So the z is going to go opposite one another. Now, if you're like, I think I might change it up here, you could have the z's on the opposite corners as well. And then the sides that it breaks up, that it works with, is the 3 and the 9. So z squared equals 3 times 9, which is 27. So z is going to equal 5 point something. Bless you. Yeah, 5.2. It rounds up. 9.6 would make it a 2. All right. So then, once I know z, this is about 5.2, then again I can find x and y using our Pythagorean theorem. So over here, I'm going to do 3 squared plus, again, I'm not going to use 5.2 squared, I'm going to use square root of 27 squared, and that comes from over there, that's where that 5.2 came from, equals x squared. So 9 plus 27 equals x squared, and this one ends up being nice, doesn't it? So x ends up being 6. And I'm crazy that that would work out. And then on this side over here, so I have square root of 27 squared plus 9 squared is going to equal my y squared. So be 108. So y is going to be like 10 point something. So 10.39. We'll take a break on those last couple ones. We'll do those in a second together. But we can maybe get up and do some would you rather just to give you guys a break sitting. All right, so I need to highlight ones that like some of these are hard to read through. All right, so pick a type of pie. We'll do that because it's just Thanksgiving. Apple pie, pumpkin pie. Apple pie over here, pumpkin pie over here. I like pumpkin pie. I like apple.
No, that was gross. I agree. Boom.
All right, would you rather have your skin feel slimy or bumpy all the time? So your skin is either slimy over there or bumpy. I don't know. They're both sound pretty bad. All right. Would you rather eat fruit roll-ups or fruit by the foot, whatever you guys want to call it, or gummy bears? Gummy bears are over here. Fruit roll-ups or gummy bears? Gummy bears give me an upset stomach. I don't know why.
Yeah, look at me. You need to know what's in you.
There must be something in them. All right, you have to get rid of a class. No pressure. You have to get rid of one of your 2 classes. Either get rid of history or math.
Oh, no. It depends which history we're talking about. It depends.
Or I guess we'll go social studies then. I don't know.
Well, if you're talking about Mr. Epic, he always makes us do like essays, class, test, everything.
All right.
Yeah, he talks about you guys.
Well, I wouldn't.
You guys
Oh,
like-
God, you guys are
you guys
pretty
like the
excited. Oh, yeah.
You guys like 3 minutes.
That was you! That's your class!
Oh, yeah.
Okay, so you get a car, but your car either has to be like a totally beaten down ice cream truck, like the creepy one that like comes down the street, you're like, don't go there, or the Oscar Mayer Wienermobile. So that's you gotta be your car. So you're driving creepy ice cream truck or the Neapolitan?
Oh!
Braids.
Buddies with the
Like, you realize there's no ice cream in the truck.
It's all ice cream if it is. All right. Would you rather have Wonder Woman for your mom or the Hulk as your dad? So Wonder Woman as your mom or the Hulk as your dad?
Can't date my mom.
Can't date my mom.
Can't do it.
All right. Here you guys go. Would you rather marry for money or for love?
Money.
Would you rather marry for money or love?
Yeah, I'll take it.
That's why I marry Miss Donahue and not the lawyer. Sorry. He knows. Okay. Would you rather? Oh, gross. Sorry. Would you rather live? You'd be a Flintstone, like in the Stone Age, or with the Jetsons? What are the Jetsons? The Jetsons are the guys who
Fly
live
around
in space.
and like, oh, yeah. Yeah.
They live in space. And they have like everything's automated, and they like fly in
Yeah.
cars.
You pilot all of them.
No, I didn't never before, but I figure I should because so many of them are bad and dumb.
By driving.
Then I can remember which ones are good.
You can drive this.
All right, lemonade or orange juice?
Lemonade.
I don't know, that was tough.
Oh, lemonade or orange juice?
I don't know.
Do you have oranges in your water bottle?
No, orange juice.
Orange juice.
That one's close.
All right.
It just, I don't like the.
Would you rather hang out with Winnie the Pooh or Curious George? Hang out with Winnie the Pooh or Curious George?
Curious.
We used to have a
I've always wanted.
where Curious George got arrested, and my kids used to call it Curious George Goes to Jail. So we have love Curious George. Find a good one to end with. All right. Sorry, I'll find a good one to end on.
Look, you are welcome. Like those pheromones? Those yeah.
Sorry. Sorry. Not finding a good one to end What are you guys doing?
Basketball.
Yeah. Sorry.
He's also kind of like
All right, would you rather your job be to like be a food critic? So you have to like test different types of food at restaurants, or a movie critic, so you go to movies and like,
Yeah, my gosh.
I'm just shouting.
yeah, it can be gross food. All right, you guys can go have a seat, sorry. And have a good.
really good sausage.
All right, so let's go to the last couple. Actually, let's start with example 6 and we'll go back to 5. 6 is a little bit easier than 5. So let's go to 6 first. Any ideas on how to set up 6? It looks a little bit different. We're used to putting the variable twice. Does anyone see what they would do in this one? Yeah, Dawson?
Instead of X, you got 5.
Yeah, this time, rather than x being the shared side, 5 is our shared side. Do you see that? So this 5 is the shared side between these two sides. So it's okay for 5 to show up twice. So this one actually, maybe it might be a little bit easier, but again, that's the shared side is that 5. So in my proportion, I'm going to put 5 twice because it's both the short side and the medium side, depending on which triangle we're talking about. What's going to be the other part of the proportion? X and 2, it divides up those two. Now, this is almost going to throw you off more because the proportion is that much easier. When you go to solve this, this is a lot nicer. 5 times 5, there's no like x squared in this case, and that's okay. But sometimes it makes you feel like you're doing something wrong. Divide by 2. So we find out x is 12.5. And once I know x, I can find y and z because, again, of Pythagorean theorem. So, like on the right side over here, these two nice little sides here, 2 and 5. So I have 2 squared plus 5 squared equals y squared. So y is going to be like 5 point something. .39. Oops. And then over here, I can figure out my z. Now 12.5 isn't perfect to use, or isn't like great to use, but it's you don't have any kind of square root to work with there. So it's going to be 12.5 squared plus 5 squared, and that's going to give us our z squared. Now this is the time that rather than retyping that, I'm going to do the square root of the answer. So I find out my z is about 13.46. So I was able to find x, y, and z based off the fact that we had that shared side. So that brings us to this last one. This last one's definitely more tough, more difficult than all the other ones we've seen so far, because they don't give us this middle side here. Any thoughts on anything that you guys noticed you could do? Yeah, go ahead, Dawson.
Let's do the a squared plus b squared plus c squared with 20 times z
Yeah, so noticing right away, Z actually in this one is probably the easiest one to find because we have 2 out of the 3 sides. Do you see that? So the big triangle, the Z is pretty easy to solve, where 20s are C. So be able to find a Z. So Z squared equals 300. So Z is going to be 17.3. So this is square root of 300. All right. So we still need X and Y. Any thoughts? This one's a tough one. Like my instinct is like, hey, I'll just pick a new variable and put it right here. Well, that's not really all that helpful because the 2 sides that are like would help us with this are unknown. So what I'm going to do in this case, and I don't know how much space you have, sorry, it's probably, hopefully your margin's a little bit better than mine, is I'm going to compare the big triangle. I'm going to draw that separately, so I'm going to draw it down here. So I have the big triangle is 10, 20, and then square root of 300, I'll just call it that, okay? Now, I actually know that square root of 300 or 10 is used with this other triangle. Like, so if you, either one of these. So I'm gonna draw, but actually, let's maybe draw this one. I'll draw the short one over here, the small one. So I drew these 2. Now, I do have a shared side now, it's 10. You notice that? So, in this case,
20 minus y.
what's that?
You do something like 20 minus y.
I guess you could, that might be a little bit of a pain. I think we can kind of even make it easier than that. So 20 is which side of this big triangle? So the small, medium, hypotenuse. Hypotenuse. Where's the hypotenuse on the little red triangle? The 10. So those 2 match up. The y is which side of the little triangle? The smallest one, the short side. Where's the short side of this blue triangle? The 10. So I can set a proportion comparing these parts. So in this, I can say, well, 20 should go with 10, and then 10 should go with y. Again, the 10 is that shared side. So 10 is used for both of them, so I can put that opposite itself in that triangle or in that proportion. And we'll use your 20 minus y in a second to figure out the x or whatever that is. You're funny. So at this point I have, so this one's definitely a tougher problem, so 20y will equal 10 times 10, which is 100. So I find out that y has to be 5. Once I know y is 5, Michael had pointed out, if I know y is 5, I can just figure out x, because 20 minus y should give me my x. So this will just be 15. So So one of the things to do, if they don't give you that really obvious shared side, is try drawing the triangles separately. So this won't come up as often as the other types, but it's still like definitely something that will come up. So just a heads up on that. So try, like if you're ever stuck, try drawing the triangles separately and see like where's the short side, where's the medium side, where's the long side, okay? So your homework is listed there. I'm gonna give you guys time now because we don't have AR today. So just in case you got stuff going on, the homework is listed there for you guys. It should be posted online. Oh, you guys, can I do one problem with you guys real quick? So, let me do 24 with you. So if you want to follow along here, 24, 25, 26 are a little bit trickier. So I'm going to do 24 with you if you want to stick with me here for a second. If you're overconfident and want to ignore me, go ahead. Actually, I should check and see. Actually, let's just change the directions for 24 to 26. Just tell if it's a right triangle. I'm just changing the directions. I won't do that one with you. That's just a review from last class. So don't do that. They talk about an altitude part, you can ignore that part. So on 24 through 26, just tell me if it's the right triangle or not. So yes or no, right. Okay?